Okay, so we're on section 4.5, and the main focus on 4.5 is finding roots, finding the roots of all types of polynomial functions. Okay, so in example 1, they asked us to find the roots of the function and sketch the graph. Remember that another word for roots is solutions, zeros, and the big key thing is another word for roots are x-intercepts. We want to find out where this graph, this cubic polynomial, is going to intersect the x-axis. Okay. So we have the function 2x to the third minus 12 of x squared plus 18x. We're going to need to find the roots or the zeros of the solutions. The first thing is we need to find where the y value is equal to 0. Okay, that's where the y-intercepts happen. That's why sometimes it's called x-intercepts, and sometimes that's why it's called 0. Because that's where your graph is equal to 0. Okay, so we have to solve this. Now in the last chapter, there were a bunch of ways to solve quadratics. There was factoring, completing the square, and quadratic formula. Factoring was the easiest, so we want to start with that. Let's see if we can factor this. Okay. So one of the first things about factoring is we want to see if there's a GCF. So is there a number that can divide all these things, all these terms, and a variable? And yeah, I can divide them all by 2, and that's the biggest thing that can divide out. So I'm going to factor out a 2 and an x. Each one of these has an x. This has 3, 2, and that only has 1. So that leaves me with 2x to the third divided by 2x. That leaves me with x squared. Negative 12x squared divided by 2x gives me negative 6x. 18x divided by 2x is a plus 9. Okay. So we want to factor completely, meaning factor until we can't factor anymore. So that x squared minus 6x plus 9, that's a quadratic, so we should try and factor that some more using the factor puzzle. So let's see. The 9 goes on the top and the negative 6 goes on the bottom. We want to think of two numbers that multiply to 9 and add up to negative 6. So multiply to 9, add up to negative 6. So then those numbers are negative 3 and negative 3. So rewriting this expression, that 2x is still there. Instead of x squared minus 6x plus 9, I can write x minus 3 squared. So that's factoring. Okay, finding roots isn't just about factoring though. Like factoring can help you find roots. Finding roots is about solving. So I need to solve this expression. This multiplied with x minus 3 squared should equal 0. And so what I do next is I split this up. If this is going to turn out to be 0, then either 2x is equal to 0 or x minus 3 squared is also equal to 0. So then I have to solve these. So if I solve on the left, I divide by 2, I get x is equal to 0. So that's one of my roots. One of the spots where my graph either crosses or touches the x-axis. And here, if I square root both sides, square root of 0 is 0, so I have x minus 3 equals 0. And then I get x equals positive 3. Okay. So those are the roots. Okay. How are the roots going to help me graph? Well, they tell me where it intersects or touches the x-axis. But also tell me how. So let's go back. Let's go back at the beginning of our function. We have 2x to the third. That's a cubic function. The first number is positive, so like the graph should kind of look like this somehow. Okay. Kind of have to look like that somehow. But it also has to intersect the x-axis at 0 and 3. So here's 0, here's 3. I want to remember what it says down here. This is a helpful tip. So what it means is that if you have a factor and it's an odd exponent or an odd power like it is here, it has to cross the x-axis. So over at 0, x to the first, that's an odd power. So at the factor 2x, x is an odd power there, so it has to cross here. But over here at x minus 3 squared, x minus 3 squared is an even power. So if it's an even power, it just touches the graph. So I cross at 0, and I touch at x equals 3, and I'm supposed to look like that. So kind of just to sketch the graph, I know I'm going to start down here, go up, I'm going to have to cross at 0, go up a little bit, I have to turn down, and then touch at 3, and then go back up. So that's kind of a rough sketch of the graph, and that's all I want from you guys, is a sketch. So if it is odd at this factor at 0, I have to go through. If it's even, I have to just barely touch. Once you guys do 2, factor it, solve it, and give me what the graph should look like. Okay. So I set it equal to 0 first before I solve. And then I want to look for a GCF. Okay. It looks like I can only take out an x squared. What's left over is x squared minus 1x minus 12. I should factor this some more. Negative 12 on the top and negative 1 at the bottom. So I need to multiply the negative 12 and add up to negative 1. The two numbers are negative 4, positive 3. So that's x squared, x minus 4, and x plus 3. To solve it, I need to separate these factors out and set them all equal to 0. Okay. So x squared equals 0. If I square root, I get x is equal to 0. X minus 4 equals 0. If I add 4, I get x equals 4. X plus 3 equals 0. If I subtract 3, x is equal to negative 3. Those are all my roots. Okay. But I need to decide if they cross there or they just touch. So I need to look at the factors. X squared, that's an even power, so that has to just touch there. X minus 4, that's only one of them. It's just x minus 4, it's not x minus 4 squared or anything. It has to cross there. And x plus 3, there's only one of them. It's not x minus 3 squared, so it has to cross there as well. Going back to the beginning, it is an x to the 4th. It's a quartic. So, and the first number is positive, so it opened up. So, like, the general shape of the graph looks like this. Okay, so I need to just put it together with these roots to get like an accurate picture, or a more accurate picture. So, here's 0. Here's 4. Here's negative 3. So I start above, I have to cross, I have to go through negative 3. I got to turn back up, but I have to just touch 0, so I have to just touch it like that and come back down. And then I have to cross and go through 4. So my graph would look like that. Okay. So let's try more difficult ones. Let's try number 3. So I need to solve it first, and I need to solve it by factoring. So I set it equal to 0 first. I want to see if there's a GCF. Is there a GCF I can divide out by? Looks like I can divide all those numbers out by 2. In fact, I'm going to divide it out by negative 2 because I don't like that. I don't like that first thing being negative. Gives me x to the 4th minus 8x squared plus 16 because I divided out by negative 2. You want to try to factor this much. Alright, what's left over there? And this is a quartic trinomial, so we also factor it using the factor puzzle. 16 on top, negative 8 on the bottom. Two numbers that multiply to positive 16 add up to negative 8 is negative 4 and negative 4. So 0, negative 2, this is minus 4 and minus 4, and in the first spots we need x squared, so they will multiply out to the x to the 4th. These two are the same, but we could factor them some more. Negative 4 on top, 0 at the bottom. So that's negative 2 and plus 2. So these factor out to x plus 2, x minus 2, and this is also x plus 2 and x minus 2. So we have to separate all these and set them equal to 0. Notice how there's two x minus or x plus 2's and two x minus 2's. I can write that as x plus 2 squared and have that equal to 0. And x minus 2 squared, and I have that equal to 0. And I don't really do anything with this 2 out in front. It's just a number. It doesn't have any variables with it, so I can't really solve anything with it. If you want to think about it, if you divide both sides by negative 2 now to solve for it, that would just go away. So that number in front doesn't really matter. It doesn't change your roots. It'll affect the graph, but it won't change your roots. Solving this now, x plus 2 squared equals 0. I can square root both sides, and that'll just give me x plus 2. The square root of 0 is 0. So one of my roots is negative 2. Same thing here. If I square root both sides, it's still x minus 2 equals 0. X equals 2 is my other root. So the question is, do I cross or do I touch? It was 2x plus 2's. It was x plus 2 squared there. So I touch here, and I also touch here because it's x minus 2 squared. Way back at the beginning, it's a quartic, and that first number is negative, so I know it opens down. So it looks something like this. So it looks something like that, and I can only touch at negative 2 and positive 2 because those are my roots. It doesn't cross anywhere though. So I have to kind of make this, I have to make it go up. Just barely touch at negative 2, come back down, go back up to touch 2, and then come back down. That's kind of how the graph would look like. Want you guys to do 4, just like that. Solve it to find where the roots are, and then sketch a graph. Okay. So I want to check for a GCF first. There is no GCF, so I'm going to try to factor this. 81 at the top, negative 18 at the bottom. My two numbers are that's, I'm blanking out for some reason. They're both negative 9. So that's x squared minus 9, x squared minus 9. If you factor x squared minus 9 some more, you get negative 3 and positive 3. So both of these factor to x plus 3, x minus 3, x plus 3, x minus 3. And you can see I can combine these two and have x plus 3 squared equals 0 and x minus 3 squared equals 0. You can square root to get x plus 3 equals 0 and x equals negative 3. I can square root and get x minus 3 equals 0 and x is equal to 3. So those are my roots. They're both squared, so they touch. And at the top I have a quartic, and it's positive up front, so I know it opens up kind of like that. So here at -3, here at 3, and you get it to touch at -3, go back up, touch at +3, and go back up. That's what my polynomial would look like. For 5 and 6, we don't have to graph. Okay? We just want to find all the solutions. They're all in solve. So we're still finding roots, x-intercepts, and whatever like that. The problem is, though, we can't factor. We don't know how to factor this. There's no GCF. There's no way to factor this. So we're going to use something called the rational roots theorem. It says that if you have something like this, one of your roots should be rational, and you just look at the last number. It should be one of the factors of 20. So just give me some numbers that is a factor of 20. So let's just try 2. So 2. I'm going to see if it's a factor by dividing it out. So 1, -8, 11, and 20. Bring down the 1. So what am I checking? I'm checking for if the remainder is 0. If the remainder is not 0, sorry, if the remainder is 0, it's a factor and I can use it. So 2, so bring down the 1, 2 times 1 is 2, adds up to -6. 2 times -6 is -12, adds up to -1, 2 times -1 is -2, and that's 18. So x minus 2 is not a factor. Okay. So I'll just try something else. We just have to try. Let's try -2. So bring down the 1, that's -2, that's -10, that's 20, that's 31, that's -62. I can already tell that's not a factor either. Okay, so let's think of another number that will multiply to 20. Let's try 4, because 4 times 5 is 20. One, 4 times 1 is 4, it's -4, -16, that's -5, and lo and behold, I get a remainder of 0. Okay, so 4 went through, so 4 is one of my roots. That means x minus 4 is my factor. Okay, so back up here. X cubed minus 8x squared plus 11x plus 20. I can factor it as x minus 4 times something. Okay. Because we just shown that 4 kind of divides it through evenly. That something is your answer from here. So the answer here is x squared minus 4x minus 5. So I should factor this some more to help me find those roots. What multiplies the -5 and adds the -4? That's -5 and a +1. So this is x minus 4, x minus 5, x plus 1 equals 0. So I can separate all of them and solve again. So this is x is equal to 4, x is equal to 5, and x is equal to -1. Those are all the roots here. Okay. So I want you guys to do 6 guess. Start with factors of 24 and just guess. See if they work out. And if somebody finds it out, you should tell the class so they don't have to stop looking for it. Right. On your test, you're going to have to look for yourself. Alright, I'm going to try 6. 1, -5, -2, 24. 1. 6 times 1 is 6. That adds up to 1. 6 adds up to 4. 6 times 4 is 24. Oh, that's 48. That's close. No cigar. Let me try negative 6. So 1, this is negative 6. This is negative 11, that's 66. I can already tell this is no good. So don't do that one. What other things should we try? 4. So let's see. Hey, 4 worked again. So x cubed minus 5x squared minus 2x plus 24 equals 0. It factors out to x minus 4 and something. We'll take the opposite sign there. And this is x squared from here. Negative x minus 6. Factoring this some more. Multiplies the negative 6 and adds up to negative 1 is negative 3 and 2. So x minus 4, x minus 3, x plus 2 equals 0. So your roots, you separate these. So your roots are x equals 4, x equals 3, and x equals negative 2.